So first we are going to find out how do we calculate empirical formula if the percentages of elements are given to you in any formula, right? So empirical formula is the simplest ratio of molecular formula which we have already discussed in your first lecture. Now how do we calculate mass percent, or what is mass percent? And if I ask you how much of hydrogen is present in water molecule in percentage, or how much of mass percent of hydrogen is present in water, then what do you do? Hello and welcome back, students. So this is going to be your 5th class on stoichiometry. This is going to be very important because we are going to talk about moles, which is a very important topic in chemistry. If you have not watched the 4 videos which we have already uploaded, then go check that out. You will find the link in the description below, and show your appreciation by liking the videos, commenting if you have any problems, share it with your friends and family, whoever needs it, and subscribe to our channel. So let's quickly dive into it without wasting any time. So let's first talk about what all topics we are going to talk in this video. So first we are going to talk about mole concept. Then we will try to understand that how moles are connected to molar mass, then Avogadro constant, and then volume of gas. By the end of this video, we will be able to answer how to calculate reacting masses, right? So now let's quickly begin. So first is your moles, molar mass, and Avogadro constant. Now what is mole? Mole is a chemist way of calculating or chemist way of measuring large number of substances. Okay, let's quickly read it. Mole is the measure of amount of substance in chemistry, right? Now 1 mole is equal to the molar mass, or I can say the formula mass, okay, or formula. How? Like if I ask you that what is 1 mole of sodium equivalent to, okay, I'm saying 1 mole of sodium Na is equivalent to its atomic mass, which is 23. If I ask you that what is 1 mole of helium equivalent to, so 1 mole of helium will be equivalent to the atomic mass of helium, which is 4. Right? If I ask you what is 1 mole of water molecule H2O equivalent to, so we have to find out the molecular mass of water, which is H2O. How do we find the molecular mass? 2 times 1 plus 16, which is equivalent to 18. So I would say 1 mole of water will be equal to 18, right? I hope this is clear. This is how we connect mole with molecular mass. So 1 mole of any substance is equal to its molecular mass, atomic mass, or formula mass, right? Now let's talk about what is Avogadro number and how is Avogadro number connected to 1 mole. So let's understand that 1 mole of substance contains 6.022 times 10 to the power 23 particles of atoms, molecules, ions, or formula units depending on the substance considered. Okay, this is very important. What we are trying to explain over here is that 1 mole of any substance will occupy this many number of 6.022 into 10 to the power 23. This number is known as Avogadro's constant. Okay, this number is known as Avogadro constant. This can also be denoted as N, and in subscript we can write A. Okay, so this is denoted as Na, and this number is known as Avogadro constant. So I can say that 1 mole of sodium, which I told you before, 1 mole of sodium is equal to 23. It means 1 mole of sodium will occupy or does contain 6.022 times 10 to the power 23 atoms, or I can say molecules or ions or formula units or electrons, right? So I hope this is clear. Quickly write it down. If you have any problem, make sure you can comment down below. I will get back to you. And after this slide, we will dive into molar mass and moles in detail. Okay. Okay. Now let's talk about moles and molar mass in detail. So what are moles and molar mass? As I told you before also, 1 mole of any substance is equal to its molar mass. Okay, it's equal to its molar mass, and there is a formula to calculate moles. So amount of substance or mole equals to mass upon molar mass, or I can say that mole, which is denoted by small letter n, equals to mass which we will be given, or we have to find out, divided by molar mass. Okay, this is a triangle, a calculation triangle for you to understand or to learn this formula in an easy way. If you have to find out the mass, then you simply multiply the number of moles and molar mass. If you have to find out the molar mass, then you simply divide mass and number of moles. Okay, next let's move on and try some questions. So, how many moles are in this gram of sucrose? So, what is already given to you? Let's quickly write down what is given to us already. Given is mass of sucrose, which is 2.64 gram, right? Molar mass is also given. If it is not given, then you can calculate. We know very well how to calculate molar mass from our previous video. So, this is the molar mass which is, okay, and they are asking what is the moles. So, we will simply apply the formula, which is moles equal to mass divided by molar mass, right? Now, let's put the values. This is the formula. Let's put the values and find out the answer. So, mass given is 2.64 divided by 342. Okay, I have my calculator with me. So, let me calculate this. 2.64 divided by 342. So, this will give you 0.00771. Okay. So, this becomes your answer. This many number of moles are present for sucrose, right? So, this will be your answer. Next, let's move on to another question. What is the mass of this moles of zinc? So, in this question, moles are given to you and they are asking about the mass. So, what do we do? From the periodic table, it is given that atomic mass of zinc is 65. So, how do we calculate the mass? So, from the above formula only, how we calculate the mass? We simply move this here and we'll multiply moles times molar mass will give you mass, right? This is the formula which I will apply here. Now, putting the values, let me change the color of the pen. So, moles given to you is 0.250 times molar mass is already given 65 equal to, let me calculate, 0.250 times 65. So, this will give you 16.25 grams because we are finding out mass. So, 16.25 grams becomes your answer. I hope this is clear. It's very easy. You simply need to apply formula moles equals to mass divided by molar mass. And to understand moles, what is mole? Mole is a way of calculating. Okay, it's a chemist way of calculating, and 1 mole is always equal to the molar mass or the formula mass or the atomic mass. Now, quickly take a minute here. Write down this, and if you have any problem, then comment down below. Now, let's move on to another part of this video, which is moles and Avogadro constant. So, as I explained you in the first slide itself, that 1 mole is equal to Na, which is Avogadro's number of particles. Okay, the particles can be of atoms, number of atoms, or number of molecules, number of ions, number of electrons, number of formula unit, anything. Okay, and the formula which we have to use is this: number of moles to find out moles. Okay, number of moles equals to given number of particles divided by Avogadro's number, which is nothing but this number. 6.022 times 10 to the power 23. The value will be given to you. This is a triangle for you which can help you to remember or to memorize this formula. Now, let's try a few questions. Okay, so the question is, in 10 gram of methane, which is CH4, how many molecules are there and how many atoms are there? The formula is already given to you. You can simply use the formula and put the values. First, we'll do the first part over here, then we'll do the second part. But before I discussed this question over here. I would like you to try this question on your own. Take a minute, take a screenshot or try this question. Pause the video here, try this question on your own. I hope you have tried. Now let's quickly solve this question. So they are saying how many molecules are there. Okay, so in this type of question, your first step should be to find out the number of moles. Okay, so how do we find out the number of moles? The formula is already given to you. So moles equal to given mass, the mass which is given is 10 gram, 10 divided by molecular mass or molar mass. So for CH4, how we calculate the molecular mass or molar mass? Mass of carbon is 12 plus 4 hydrogen. So 12 plus 4 gives 16, right? If you solve this, you will get, so the number of moles will be 0.625. Okay. Now, they are asking how many molecules are there. So, we know that 1 mole contains 6.022 times 10 to the power 23 molecules, right? So, 0.625 moles will contain how many? Okay, how many? So, now what do? We simply cross multiply. Okay, we will simply cross multiply this and you will get 0.625 times 6.022 equals to, let's calculate this quickly, 0.625 times 6.022, which is going to give you 3.76 times 10 to the power 23 molecules. Okay. So, how many molecules will be there in 10 gram? First, we are going to convert this into moles. Then we know that 1 mole of any substance contain Avogadro number of particles, right? So, we will find the moles. Moles we will get 0.625. Then we will simply cross multiply and we will find the number of molecules, right? Now, the second part says, let me change the color here. The second part says how many atoms are there. Okay. So, 1 mole of, or I can say 1 molecule of CH4 contains how many atoms? 5 atoms, right? 1 of carbon and 4 of hydrogen, correct? So, how many molecules are present? We have to check the answer of first part only, right? So, 3.76 times 10 to the power 23 molecules will contain how many atoms? Now, simply what we are going to do, cross multiply. Okay, if you cross multiply, you simply multiply 5 with 3.76 times 10 to the power 23, which will give you 18.8 into 10 to the power 23 atoms. Okay, so this many number of atoms will be present in 3.76 times 10 to the power 23 molecules, right? I hope this is clear. If you have any doubt, please take a minute here, quickly note it down. I hope you have noted this thing down. Now let's move on to another similar type of question. The question says for magnesium chloride MgCl2, calculate the number of, so A part or first part says molecules in 1 mole. So we know that 1 mole of any substance contains Avogadro's number of molecules. Okay, so 1 mole of magnesium chloride MgCl2 will also contain Avogadro's constant, which is 6.02 times 10 to the power 23 molecules. Okay, so this is your answer. Next is your second question. A second question says atoms in 1 mole. Okay, so how many atoms do you see in MgCl2? There are 3 atoms in total, right? So to find atoms in 1 mole, what do we do? How many atoms? 1 magnesium and 2 chlorine, right? So 3 times 6.02 times 10 to the power 23, which will give you 18.06, okay, which will give you 18.06 times 10 to the power 23, right? Next is your third part, which says chloride ions in 1 mole. Now, how many chloride ions do you see here? 2. Okay, 2 chlorine ions or chloride ions are present in magnesium chloride. So, I can say chloride ions in 1 mole will be equal to 2, because 2 chloride ions are present, times Avogadro's number, which is 6.02 times 10 to the power 23, which will give you 12.04 times 10 to the power 23. Okay, this is your answer. Next is your fourth part. So, magnesium ions in 2 moles. In 1 mole of magnesium chloride, how many magnesium is present? Only 1, right? Magnesium chloride is MgCl2. In 1 mole of magnesium chloride, only 1 is present. So, in 2, how many will be present? So, Mg ions in 2 moles will be equal to 2 times 6.022 times 10 to the power 23 equal to 12.04 times 10 to the power 23. So, this is your answer. Now, quickly write this thing down, then we'll move on. Okay. Now, let's move on to the third very important relation, which is between moles and volume of gas. Okay. So, for this, we first need to understand what is Avogadro's law. So, Avogadro's law states that equal volumes of different gases contain the same number of molecules when the temperature and pressure remains the same. Okay. For example, you have a balloon or maybe 3 balloons filled with different gases. Maybe this is nitrogen gas, oxygen gas and helium gas. Okay. And all the 3 balloons are kept under same temperature and pressure, right? And another thing, that equal volume of nitrogen, oxygen and helium is present. Let's say V volume, V volume, V volume. So, volume is same, temperature and pressure remains the same. Let me write temperature and pressure, temperature, pressure, temperature, pressure. All these 3 conditions are same, even if the gases are different, but the number of molecules of these gases inside of this balloon will remain the same, right? This is what Avogadro's law states. Now, what is standard room temperature and pressure? So, standard room temperature and pressure in short can be called as RTP. Okay, room temperature and pressure. And what is this condition in which room temperature is considered to be 20 degrees Celsius and pressure is considered to be 1 atmospheric or 1 atm. Okay, then what 1 mole and volume of gas relation states that 1 mole of any gas occupies 24 dm cube, or you can also understand it as 24 liter. Okay, whatever feels right with you. So, 24 dm cube or volume. Okay, this relation between mole and volume is only this only implies for gases. Okay, because only gases can flow and they can have volume. So, I am saying that 1 mole of any gas will occupy 24 decimeter cube of volume. Okay. In terms of centimeter cube, if you have to convert, you have to simply divide decimeter cube by 1000 to convert it into centimeter cube. Okay. So, I can also say that 1 mole of any gas occupies 24,000 centimeter cube of volume. I hope this is clear. This volume is known as molar gas volume at RTP. Okay, this is known as molar gas volume at RTP. What is RTP? Room temperature and pressure. What is room temperature? It is considered to be 20 degrees Celsius and the pressure is taken as 1 atm. Right? I hope this is clear. What is Avogadro's law? Avogadro's law states that under same conditions of temperature and pressure, and if the volume of gases, different gases are taken to be same, then the number of molecules present in those gases will also be same. Right? Now, quickly write it down. Okay, now let's move on and try a few questions of moles and volume of gas. Before that, let's talk about the formulas here. Volume of gas, if we have to find out the volume in centimeter cube, then number of moles of gas times 24,000, okay, because 24,000 is the 24,000 centimeter cube is the volume which occupies a gas occupies at room temperature if it is 1 mole, and volume of gas if I have to find out in decimeter cube, then we will simply use 24. Okay, now the question, find the volume in centimeter cube of a gas that consists of 4.6 moles. So what is given here? Given is moles, which is 4.6 moles, and we have to find out volume. So how do we find out the volume? We have to find out the volume in centimeter cube. So we'll use this formula, right? So volume of gas in centimeter cube will be equal to 24,000, because we have to find in the centimeter cube, times what is the moles given? 4.6. So 4.6. Now let me use my calc and find out the answer. 24,000 times 4 point will give you 110,400, right? So this much of, in centimeter cube, this much of volume will be occupied. Okay, if I have to convert this into decimeter cube, I can also say or 110.4 dm cube. Okay, dm cube, right? Now let's move on. Okay, so one more question. Given that there are 5 moles of nitrogen gas, 5 moles of nitrogen gas, okay, given is 5 moles of N2. How can you determine the volume of this nitrogen gas at standard temperature and pressure? Okay, nitrogen gas. So volume we have to find out. So the formula is also mentioned here. So how do we calculate? Volume equals to 5 times 24. Why 24 this time? Because we have to find out in terms of dm cube, right? Decimeter cube. Okay, so we will find in decimeter cube. What do? We simply calculate this and you will get 120. So 120 dm cube is the volume which will be occupied by 5 moles of nitrogen. Okay, so this is your answer. If you have to find out this answer in centimeter cube, then what do? You simply divide this by 1000. Okay, and you will get the answer in centimeter. Now let's move on. Another question. If a gas occupies a volume of 672 dm cube, this time what is given to you? This time volume is given, which is how much? 672 dm cube. At RTP, how many moles of the gas are present? So we have to calculate the number of moles. So the formula to calculate the number of moles is number of moles equals to volume of gas. Now let's find out the moles. So moles equal to volume of gas, which is given 672 divided by 24. Okay, divided by 24. Now let's calculate this and find out the answer. 672 divided by 24 will give you 28. So 28 moles will be your answer. Okay, if you have to find out this answer and centimeter cube of volume is given to you, for example here decimeter cube is given, if centimeter cube would have given to you, then you will first convert the centimeter into decimeter and then put the values. Okay, make sure that you are putting correct values with the correct units. Okay, then only you will get the correct answer. Quickly write this thing down, then we'll move on. Okay, now let's move on to the last topic of this video, wherein we will be calculating the reacting masses. Okay, this is going to be very easy. We are going to use our basic ratio and proportion methods. Now let's try. Magnesium undergoes combustion to produce magnesium oxide. The overall reaction that is taking place is shown in the equation below. So the reaction is given to you. Okay, first step to solve this type of question is you have to check if the reaction is balanced or not. Okay, that is a very important step. First you have to check if the reaction is balanced or not. In the reactant side 2 magnesium, product side 2 magnesium, reactant side 2 oxygen, product side 2 oxygen. Yes, this reaction is balanced. We can move on now. Calculate the mass of magnesium oxide MgO that can be made by completely burning 6 grams of magnesium in oxygen in the following reaction. Okay, so over here we have to talk about or we have to focus on only two things. Which one? Magnesium. Okay, magnesium and magnesium oxide, that's it. Okay, so from this balanced reaction you can see that magnesium and magnesium oxide are present in 2:2 ratio. Okay, they are present in 2:2 ratio, or I can say they are present in 1:1 ratio if I simplify this. Okay, so I can say that the mass of reactant side should be equal to product side. So 2 mg mass will be equal to 24 plus 24, or 24 times 2, which will give you 48 gram. Okay, and mass of MgO or 2 MgO will be equals to 2 times 24 plus 16. Okay, the values are given to you over here. So let me calculate. 24 plus 16 times 2, which will give you 80 gram, right? So from this I can say, let me make a statement here, that 48 gram of Mg or magnesium is required to produce 80 gram of magnesium oxide, MgO, right? So they are saying calculate the mass of MgO produced after burning 6 gram of magnesium. So can I write it like this? 48 gram producing 80 gram of MgO. So 6 gram of Mg will produce how much? Now what we are going to do, we will simply cross multiply. If you will cross multiply, or if you wish to do it like this, 80 divided by 48 times 6, this will give you, let's calculate, 80 times 6 divided by 48, this will give you 10. Okay, so 10 gram of magnesium oxide will be produced if we will burn 6 gram of magnesium. I hope this is clear. Take a minute here and note it down. Okay, now let's try one more question like this. In this question, they are saying calculate the mass of calcium oxide, CaO, this formed when 6 gram of calcium reacts with excess oxygen. Okay, so this reaction is also balanced. Okay, you can see the masses are not given, so let me write it down here for you. Calcium is 40, oxygen is 16. Okay, the values will be always given to you, or you can refer to periodic table also. So these are the atomic masses. So from this equation I can say that 2 mole of calcium requires to form 2 mole of CaO, right? This is in terms of mole. Now let's convert this into mass. So what do we do? Moles equals to given mass upon molar mass. So what do we do? 2 moles of calcium means 40 times 2, which is 80 gram of calcium is required to produce 2 times calcium oxide mass. Let's find out calcium oxide molar mass, which is going to be 40 plus 16, which is 56. 56 times 2, which is 112. So 112 gram of CaO. Okay, so 80 gram of calcium is required to produce 112 gram of CaO. Is this clear? So 6 gram of calcium will produce how much of CaO? Now simply we can cross multiply. Okay, you can either cross multiply or 112 divided by 80 times 6, this will give you 112 times 6 divided by 80. This will give you 8.4. So 8.4 gram of calcium oxide, let me write it down here, 8.4 gram of calcium oxide CaO is produced from 6 gram of calcium. Okay, comes your answer, 8.4 gram. I hope this is clear. Take a minute and note this thing down. I hope this is clear. Here we come to an end of the 5th class of stoichiometry. I hope this video helped you to understand mole concept in a good way. If yes, then show your appreciation and wait for the 6th class. It is soon going to be live on YouTube, and before that, keep learning and enjoy. Thanks for watching, and I'll see you in the next video. Till then, don't forget to like, share and subscribe to our channel.